Thank you, Chairman. Good afternoon, everyone. My name is Kwang Park. I'm working for Operational Ocean Forecasting Research Center in KIOST. This afternoon, I'd like to talk about the cooperation for management of coastal extreme weather event in the Pacific Island and the Southeast Asia region. Okay, as you know, the most of the coastal extreme weather event in the Pacific region are caused by a tropical cyclone, and such as a cyclone and the typhoon. As you know, tropical cyclones are called hurricane, cyclone, and typhoon, depending on where they occur. So this kind of tropical cyclone caused huge damage to people and property. Okay, let's look at the list of severe tropical cyclone typhoon in the Pacific Island and the Sea region from now. In case of the PG, Category 5 tropical cyclone Winston hit PG in February last year. And then causing 44 casualty and huge damage like this. In case of Philippines, Typhoon Sarika hit the Philippines in October last year, and 34 casualty and huge property damage like this. And 3 days after Typhoon Sarika hit Philippines, Category 5 Typhoon Haima hit again the Philippines, then causing 19 people killed, and property damage was 1.9 billion at the time. So then how do we respond to this kind of severe extreme weather event? How can we reduce some damage from this kind of cyclone? So we can see that operational oceanography system is one of the way to resolve this kind of problem. So KIOST has been developing and operating Korea operational oceanographic system in the surrounding waters of the Korean Peninsula since 2009 at the request of the Ministry of Ocean and Fisheries. The main objective of KIOST is to produce and provide nowcast and forecast of ocean information to reduce coastal disaster and to support various marine activity. So, KIOST system consists of the 3 parts like this. The first one is real-time monitoring system using various types of platform, including satellite. Currently, more than 200 real-time monitoring stations operating by different government agencies in Korea. Second is numerical model system. So the third is the application system. Okay, this slide shows what KIOST is doing at a glance. As shown here, the KIOST system is systematically and directly linked from weather forecasting to applied forecast. There are two categories in the KIOST system. The one is basic forecast, the other one is applied forecast. In basic forecast, there are operational weather forecast, operational circulation, 3-dimensional circulation, and operational sea state forecasting system. Then result of a basic forecast is used for applied forecast such as oil spill, red tide, and search and rescue, and so on. So now we operating this KIOST system every day, and then we produce 72-hour forecasting information every day. Okay. Each year, 1 or 2 typhoon affect Korean peninsula. Sometimes typhoon land on Korea, then left huge, great damage, like this. Okay, then using KIOST system, we can forecast typhoon wind and typhoon storm surge and typhoon wave. This is the wind, typhoon wind. Okay, this is the forecasting result. During the typhoon, okay, this is the typhoon wind, typhoon wave. So we can know when highest wave occur. Then we can take a necessary measure, and we can reduce the damage from typhoon. Then this is the KIOST safe navigation system. We can provide this kind of forecasting information to user using through the internet, like this. Okay, this slide shows the view of the Busan port. Busan port located in the southeast of Korea. We set up the high-resolution port wave prediction system. Then we can produce the high-resolution wave forecasting information during the passage of the typhoon, like this. The horizontal resolution is less than 10 meters, in this case, and 2 meters. Okay, then we've experimentally set up some operational forecasting system in PG, Chuk, and the Philippines. Okay, I will talk about the operational wind wave circulation forecasting system in PG. This is the super cyclone Winston in February last year. More than 160 knots, the maximum wind gusts were observed at the time. Okay. This is the example of the circulation forecasting in waters of around the PG. This is the coastal wind and the wave during the passage of the cyclone Winston. Then you can see the time series of the wind and the wave height around the waters of the PG during the passage of the super cyclone Winston last year. Okay, I will talk about the operational wind, wave, and circulation forecasting system in Chuk. You know, this is our research center in Chuk. We need some detailed forecasting information, especially sea state, to support the ocean field survey, and then mooring activity in around waters around the Chuk. So we established some forecasting system in around the waters of the Chuk. This slide shows the example of the result, regional coastal circulation, three-dimensional circulation in Chuk. Okay. This slide shows the wave forecasting. Our center located here. And this is the Weno Island in Chu. Then we are checking the performance of our forecasting information by using the observation data all the time. Then we are focusing on the improve of the forecasting performance. Okay, for this workshop, we set up some sea-state forecasting system in Philippines. Okay, this is the example of the three-dimensional circulation, the waters of around the Philippines. You can see two typhoons of Sarika and Haima. And these two typhoons hit the Philippines last October last year. Then in time difference maybe three days. Okay, so this is the result of simulation, typhoon wind and typhoon wave during the passage of the typhoon Sarika and Haima. You can see the typhoon, two typhoon, and Sarika and Haima. Yes, two. After 3 days, 3 days after typhoon Sarika hit Philippines, then Haima hit again the Philippines, like this. Okay, we think we can develop and improve the some basic technology for operational oceanography through the international cooperation, I think. So I think we can think of some kinds of joint research and conference, and the other one is the joint research. And we can improve some performance of the operational oceanography. So, for example, through some kinds of joint workshop, we can exchange the research result and operational experience, know-how, and discuss about the common interest. Then, through this kind of activity, we can improve existing cooperation and build up new collaboration and network, I think. Okay, this slide shows the report, the STAR 2016 conference, which this conference was held in Nandi, Fiji, last June. So at the time, about 100 participants attended this conference. At the time, 6 research scientists from KIOST and attended this conference and present 8 research results and discuss about some way to cooperate each other in the future. Okay. Now I would like some operational state forecasting system in Indonesia. Yeah. Okay, we set up this kind of operational system in Jakarta Bay, Indonesia, in 2015. Okay. Okay, this is the last slide of my presentation. Tropical cyclone causes strong wind, storm surge, and high wave, and they are one of the most serious causes of human life and property damage on the coast and the Pacific region. So, development of the improvement of operational oceanography system is needed through the international cooperation with the Pacific community and the countries in the sea region. Thank you.